The second derivative test, probably the simplest thing I'm going to teach you all year. We've got 13 minutes left to go in class. I could teach you the first derivative test in 60 seconds, but I'm not going to because I don't know, I'm not that sort of teacher. So here it comes. Second derivative test to analytically when I say analytically, that means I'm not doing it numerically. I'm not doing it with a graphic calculator. I'm doing it using algebra. The second derivative test to analytically determine if critical points are relative mins or maxes. The only problem is this only works on critical points where f prime is equal to 0.
Only f.
Only works on critical points where f prime of x is equal to 0. If you get a critical point where the first derivative is undefined, don't do second derivative test on it because it's not going to do you any good. Tell me, relative min, if this is a relative min and it's a f prime equals 0 situation, is your graph always going to be concave up or concave down at the point where you have a relative min?
Concave up.
How do you know?
Because it's at the bottom.
This is the lowest point on the graph.
Yeah, because my hand is making a happy face,
Yeah.
right? Concave up. Tell me, if I have a relative max, now, is the second derivative going to be positive or negative?
Negative.
How do you know?
Because it's upside down.
Because my hand is making a sad face. You guys okay with that?
Yeah.
Okay, that's it. That's the second derivative test, pure and simple. Here, I'm going to write it up in math language, but that's pretty much it. Here comes the second derivative test. If f prime of c equals 0 and f double prime of c is less than 0, then f of c, I'll let the video world know that I made it, then f of c is a relative. You guys tell me, what would f of c be, a relative min or a relative max?
Max.
Concave down. If you need to use your hand during a test, I'll allow that. If you need to do that during a test, that's fine. Relative max, concave down, relative max. Okay? If f prime of c equals 0 and f double prime of c is greater than 0, then f of c is a relative min. Okay? You tell me, what if f double prime isn't less than 0? It's not negative. What if f double prime isn't positive? What if f double prime is 0? What then?
It's an inflection point.
No, not necessarily. But I'll tell you what, you have to do first derivative test. That's it. What about those critical numbers where f prime is undefined and not 0? Can't use second derivative test for those. What special test that isn't second derivative test are you going to have to use?
First derivative.
Yeah, exactly. So if f prime of c is undefined, and, you know, or I don't know, and or, I don't know. No, or, I guess I'll just say or f double prime of c equals 0, use first derivative test. Because the second derivative test isn't availing you anything. Okay? So here we go. Here comes example number 1. F of x equals x to the third power minus 12x minus 5. Here's the process you're going to go through. Number 1, as always, find the critical numbers. That is the x values. So let me do that now. I got f prime of x equaling 3x squared minus 12, which equals 3 times x minus 4, whoops, x squared minus 4, which is 3 times x plus 2 times x minus 2. So I set that equal to 0. And I find I have critical numbers at x equals plus or minus 2. You guys okay with that? So far, so good. Okay, next step. Are those critical numbers that make f prime equal to 0, or do they make f prime undefined? These guys, are these critical numbers that make f prime 0 or undefined? 0. So do I get to use second derivative test? Heck yeah. Let's use second derivative test. Do second derivative test. Which means I've got to take the second derivative. F double prime of x equals 6x. You guys okay with that? And then I check the points. You'll notice there's no intervals happening here. First derivative test and check for concavity has those intervals. It has that table. Second derivative test doesn't have the table. All you do is plug into the second derivative. You just go, okay, what's the second derivative of -2? Is it plus or minus? Well, the second derivative, f double prime of -2 is -12, right? Which means it's negative. So tell me, what do I have at x equal -2, a relative min or a relative max? I can't seem to recall, but I know it's concave down, oh, max. You guys okay with that? So I got a relative max at x equals -2. Here, let's do the second derivative test on f equals 2. When I stick in a 2, I get 12. That's positive. I'm concave up at 2. So that give me a relative min or relative min? Yeah, exactly. That's what I have to do. I literally do that. I do it in my head, but you know. So yeah, I got a relative min at x equals 2. That's it. When those of you who had Mrs. Lofgren last year, when you were doing analytical tests to find relatives, mins, and maxes, you almost exclusively did second derivative test.
No,
So you, what's that?
We did first and second.
Yeah, but I mean, I taught from that book one year, and they seem to really prefer second derivative tests. I mean, I found myself, the ratio of first to second derivative test was like 1 to 10 or something. I don't know, do you guys remember? Or am I wrong? Were you, Fatima, you're doing second derivative test mostly. Yeah, thank you very much, Fatima. Thank you for supporting me here on this. Yeah. Okay, you guys ready to do one on your own? Okay, here it comes. F of x equals -x squared. Here, just 1 second. No. I'm going to make one up. I have one on my sheet, but it's way too simple. I'm going to make one up. -x to the third. Wait. 27? Wait. 18? No. 9. 27? Give me 9. Yeah. 27. Plus 27x plus 5. Okay, good luck, you guys. I'll just give you another difference of squares thing. I like difference of squares, they're fun. Then the mins and maxes, relative mins and maxes using second derivative test. For that guy, for example number 2. Let me get rid of this. done? How many people got relative min at x equal -3, relative max at x equal -3? Yay, good for you guys. Okay, good. And that's all there is to it. I want to remind you again, first derivative test and check for concavity, have those tables. Second derivative test, you're just plugging a single value into the second derivative test. And by the way, if someone was interested in what the relative maximum point is, then yeah, you're going to have to stick 3 into the original equation. So I stick 3 in here, I get -27 plus 81, which is, what is that, 54? 54 plus 5 is 59. So yeah, if they want the maximum point, it'd be 3 comma 59. But I didn't want to go to the trouble of plugging it in. Let me ask you another question. Under what circumstances would I want to do second derivative test? And under what circumstances would I prefer to do first derivative test? When would it be a good time to do second derivative test? Yes, Daniel?
Do second derivative when the first derivative is equal to 0 or,
Okay, if the first derivative is equal to 0. But that's true. But let me just ask you this. Let's say I got some function, and I took the first derivative, and I found critical numbers. And now I have to decide to do whether I do first derivative test or second derivative test. And I could do either if I wanted to, so I have to choose. Under what circumstances would you choose second derivative test, and when would you choose first derivative test? How about the problem we did together today, the really, really hard problem? Would you want to try to do second derivative test for that? No, why not?
It's in straight line.
Yeah, because it's hard. Because getting the second derivative is a son of a gun, right? Only do second derivative test if getting the second derivative is really easy. If getting the second derivative is going to take you 5 minutes, don't do second derivative test. Good luck, you guys.